Welcome to the video on modes of natural selection. So there are four main modes of natural selection that we can look at based on Darwin's theory of natural selection. And we're going to look at the four main modes so that you can classify them. So first of all, we talked about this a little bit. We talked about Darwin's theory of natural selection. But a selection pressure is a factor, often environmental, that favors a certain phenotype. So when we were talking about Darwin's finches, the selection pressure in the environment was the food available, and the birds that had the beaks that are most adapted to eat the food or reach the food were the ones that were able to survive, reproduce, and then pass on their traits. Selection pressures are usually due to changes in weather, availability of sort of like places to live, temperature also, we'll see when we look at some of the extinction events. Availability of certain food sources also is a selection pressure. Sometimes also predators are an example of a selection pressure. Over the course of the evolution unit, we'll see lots of different selection pressures that force natural selection on a population. So the first type of natural selection is directional selection. And obviously there's no writing here, so you have to write what I say, which makes you have to think more. So here we have a population of, I guess, mice, okay? And the non-dotted line is the original population, and the dotted line is the evolved population. And in directional selection, okay, the selection pressure shifts, so it favors one of the phenotypes that is towards one of the extremes. So here, we're shifting all the way towards, or the population is shifting towards darker mice. Perhaps the environment has become darker, so they're more able to blend in and therefore less being able to be seen by predators. But in directional selection, okay, the population shifts to favor one of the extremes. It also could shift in the opposite direction to favor like maybe a white mouse. But again, in directional selection, it favors one of the extremes. This obviously, if you think about our statistics, would change our mode median. Our mode would increase, right? Because now the highest or amount are a darker color, if you're going to say that darker colors have higher numbers. And our mean would probably also increase here, or would increase if you could classify darkness with a number of like a level of being dark, being a higher number. Obviously that would also increase as well, because the population overall is shifting to the right. Next is stabilizing selection. And stabilizing selection favors the intermediate phenotype. So here we would favor, instead of not, the extreme phenotypes would be disfavored. So the white mouse and like the black mouse would be disfavored, and the intermediate phenotype is favored. So this changes one of the major sort of ways in which we measure population, is that it changes the standard deviation. And it makes the standard deviation much smaller, okay? Because all the mice now have similar phenotypes, and again, if you could quantify color with a number, you know, they would all be around the same number of tanness. Sometimes stabilizing selection is not good for a certain population, because it reduces variability in the population. The last type of selection that is sort of quantifiable by number is disruptive selection. And in disruptive selection, the intermediate phenotype is disfavored, and both extremes are favored. Okay? Now this usually leads to a type of, this can lead to speciation, or a formation of two different species, because then sometimes, and we'll get into this much later, well not much later, but later in the evolution, we don't have much time, so much later is relative, but maybe in about a week and a half, this type of selection often, or can lead to different types of species, because often the white mouse and the black mouse won't interbreed anymore. But this is the most likely form of selection that is bound to lead to speciation, which we're going to talk about how new species develop sort of towards the end of this unit. So, when we talked about this example when you guys were in 10th grade, in Britain or in Europe, there was something called the Industrial Revolution, and people started using coal, burning coal for energy, and there was also, they had, what were those trains called? Steam trains. And as a result, a lot of the trees that were once white became covered with soot and became black. Before this event occurred, most moths in Britain were white, and there were very few dark moths. But what happened is there was a selection pressure or a change in environment. And because of the industrial evolution, many of the barks of the trees became darker in color. As a result, instead of the white phenotype being favored, the black phenotype was favored. Why? Because the white phenotype stood out and therefore was more likely to be eaten by birds. As a result, over time, more black moths survived. Therefore, more black moths reproduced. Therefore, more black moths passed on their traits, and therefore most moths in Britain at this time became darker in color. This is an example of directional selection, because you're shifting towards one of the extremes, which is the black moth. A different type of selection that is not sort of like shifting towards one of the extremes, as my phone goes off, is called sexual selection. And sexual selection is when females choose mates, male mates, with specific traits that they find attractive. So, for example, in peacocks, male peacocks have this large wingspan, and females will choose peacocks with the wingspan that they like the best. This is also true with lions, so females prefer lions with darker, bigger manes. There's also a species of bird called bowerbirds, and male bowerbirds during mating season build a nest with lots of sort of like shiny things from the environment. They'll go through garbage and find shiny things and build a little like home. And females will select the bird or the male bowerbird that builds the best or most attractive nest to meet her needs. And actually, if she really doesn't like the nest, she usually destroys it. And sexual selection is a way of keeping productive traits in the population. They're a sign that the male is fit to take care of the offspring and also has the traits that are necessary to produce healthy, successful offspring. In the homework, you're going to have a task, so you don't have to do this here, but in the homework, it says here's a place for your task. It's to make up a fake organism with certain traits, and you need to include variation in the traits. And then pick out an environmental change, okay, that would cause one of the modes of selection we discussed in this video. And this is the last question in the guided questions. So that's your task, and there will be other homework. Again, we don't have class Monday, so you have until Tuesday to do this homework. But I will see you guys on Tuesday.